Hello, this is Britt Caswell with another example video. In this video, I'm covering example 4 from section 4-3 in the SavvasRealize Algebra 1 textbook. So this example is all about choosing a method of solving. So it's trying to determine which method would be the easiest if you're kind of lazy like I am. So recall our three methods. Alright, we have graphing, we have substitution, and then we have elimination. So those are the ones that we're going to choose from. Now, right away with these, I know that I want an exact answer with all of these. So I'm just going to cut out graphing right away. Because with graphing, you can assume that you have a whole number solution, but you don't always know. So I don't like graphing. So I like to choose between substitution and elimination. So if I'm trying to choose substitution, what I'm looking for is a variable is already by itself, or a variable is already isolated. So for example, on A here, you could see that the y is already by itself. Now for elimination, you're usually looking to see if the coefficients are matching, or if it's easy to multiply one of the equations in order to get matching coefficients. Alright? So matching coefficients or easy to multiply to make them match. So let's go ahead and let's try this. So for A, the y is by itself, so I'm going to go ahead and I'm going to want to use substitution on this one. So I'm going to take this teal equation, and where the letter y is on the second equation, I'm going to replace it using substitution. So here we are. So here's the orange equation. I have 2x plus 7, and I'm going to leave room for the y. And with substitution, when I do that, I need to make sure to use parentheses when I go to put in the x plus 13. Alright, remember, if you don't use those parentheses, you're going to get a incorrect solution. So now I'm going to go ahead and distribute. So 7 times x is 7x, and 7 times 13 is 91. Now remember, the rest of the equation is still there, so I still have a 2x, and this all still equals 10. So now I collect my like terms. So 2x plus 7x is 9x. And then we want to start to get the x alone. So I'm going to subtract 91 from each side. So I get that 9x is equal to negative 81. And then if I divide by 9 on each side, I get that x is equal to negative 9. Now that I know what x is, I could go back either to the blue equation or to the orange equation, and I can solve for y. It doesn't matter which one you choose. I like to go back to the blue one just because the y is already by itself, and honestly the equation looks a little easier. So here, negative 9 plus 13 is 4. So my final answer is the ordered pair negative 9, 4. And remember, you have to answer it as an ordered pair because that's where those two lines intersect. Now for part B here, for part B, it's going to be really hard if I want to use substitution because none of the variables have a 1 for a coefficient. So I'm probably going to want to use elimination here. Now if you notice, on this top equation, I could get the y's to match fairly easily if I multiply the top equation by a -2. And so that's what I'm going to do here, is I'm going to multiply both sides of this equation by -2. So 8x times -2 is -16x. -2y times -2 is a plus 4y. And then -8 times -2 is a positive 16. Now the second equation, I don't have to change it because I already have a 4y here. So I have 5x minus 4y is equal to 17. So if I'm using elimination here, I am all set up to just add the two equations together, and these y's will be eliminated. So negative 16x plus 5x is negative 11x, and 16 plus 17 is 33. So if I divide both sides by that negative 11, I get that x is equal to -3. Now I can go back to any of these equations and substitute that -3 in here. I think it looks a little easier for me to use this one, so I'm going to go ahead and use the black equation. But it doesn't matter which one you choose. It's going to work the same way every single time. So -5 times -3 is -15. So I'm going to actually add that 15 to each side to work on isolating y. So this turns into -4y equals 17 plus 15, that's 32. And if I divide by -4, I get that y is equal to -8. So my final solution is the ordered pair, -3, -8. Alright, so now on this one, substitution's kind of a pain in the neck because these aren't all divisible by easy things, although I could divide by 6 here and then substitute. But that's 2 steps to get the variable by itself. That seems like a lot. I could multiply the bottom equation by 2, and that'll really make my my coefficients match. So I'm going to do elimination here because it's easy to make the coefficients match. Alright, so on the bottom equation, I'm going to times the whole thing, not by 2. Well, I could do it by 2 if I want to make the 6 matches. Yeah, let's do it by 2 actually. I'm going to do it by a -2. That way my 6's match. I can multiply by 6 if I want to make my y's eliminate, but 6 is a bigger number than 2, and I want to deal with the smaller numbers that I can. Okay? So the first equation isn't changing. It stays as 6x plus 12y equals -6. But the second equation, I'm timesing everything by -2. So 3x times -2 is -6x. -2y times -2 is a positive 4y. And -27 times -2 is a positive 54. So now if I add these two equations together, my x's will cancel. So 12y plus 4y is 16y. And -6 plus 54 is 48. And if I divide both sides by 16, I get that y is equal to 3. So now I can go back to any equation that I want, and I could solve for x. I guess I'll do the original black equation, or the black equation. It doesn't really matter which one you want to do. So here, 12 times 3 is 36. And so I'm going to subtract that from each side of the equation so that the x is alone. And then I divide by 6, and I get that x is negative 7. So my final solution is negative 7, 3. Now on part B here, do you see how the x is already isolated? So in a situation like this, it's probably easier to just substitute into the first equation. And so that's what I'm going to do, is I'm going to rewrite this red equation, leaving a nice big space for the x's. And remember, when you substitute, you need to make sure to use parentheses. So then you distribute to the parentheses. So 3 times 6 is 18, and 3 times negative y is negative 3y. And I still have the negative 2y and the 38. Don't forget those. So then I combine my like terms. So negative 3y minus 2y is negative 5y. And then we need to get y alone, so I'm going to subtract 18 from each side, because you have to get rid of that addition and subtraction. And then if I divide by the negative 5, I get that y is equal to negative 4. So now that I know what y is, I can plug in to solve for x. I'm going to do the orange equation because x is alone. And so 6 minus negative 4 gives me an x value of 10. So my final solution is the ordered pair 10, negative 4. Alrighty. So I hope that this helps you to decide which method to use in order to solve. Until next time.